It is possible to route a gas pipe through an electrical room as per the National Electrical Code. However, several critical requirements must be met to ensure safety and compliance. The most important condition is that the gas pipe must be enclosed within a fire-rated enclosure. This enclosure serves as a protective barrier, isolating the gas pipe from potential electrical hazards and mitigating the risk of fire spread in the event of a gas leak or electrical fault. Fire-rated enclosure must be specifically listed for use with gas piping. This listing ensures that the enclosure has been tested and certified to withstand the specific conditions and hazards associated with gas piping systems. The listing will typically be provided by a recognized testing laboratory such as Underwriters Laboratories or Intertek. This listing provides assurance that the enclosure will perform as intended in a fire situation. All penetrations into the fire-rated enclosure must be properly sealed. This includes penetrations for the gas pipe itself, as well as any other openings or access points. The sealing material must be fire-resistant and compatible with both the enclosure material and the gas piping. Proper sealing prevents the passage of flames, smoke, and hot gases through the penetrations, maintaining the integrity of the fire-rated enclosure. The NEC doesn't provide specific details on how to select a fire-rated enclosure. It is important to consult with a qualified engineer or fire protection specialist to determine the appropriate fire rating for the enclosure based on the specific characteristics of the electrical room and the gas piping system. Factors to consider include the size and layout of the electrical room, the type and pressure of the gas being transported, and the potential fire hazards present. The fire rating is typically expressed in terms of IRs, such as a 1-IR or 2-IR fire rating, indicating the amount of time the enclosure can withstand exposure to a standard fire test. Selecting the appropriate fire-rated enclosure is crucial for ensuring the safety of the electrical room and preventing the spread of fire in the event of an emergency. Here are some additional considerations related to routing gas pipes through electrical rooms. Firstly, verify local codes and regulations. While the NEC provides a general framework, local codes and regulations may have additional requirements or restrictions on routing gas pipes through electrical rooms. It is essential to consult with the local authority having jurisdiction, often abbreviated as HA, to ensure compliance with all applicable codes. Secondly, coordinate with other trades. Routing gas pipes through electrical rooms requires careful coordination with other trades, such as electricians, plumbers, and HVAC technicians. This coordination ensures that the gas pipe is installed in a manner that does not interfere with other electrical equipment or systems, and that all work is performed safely and efficiently. Thirdly, proper labeling and identification. The gas pipe and the fire-rated enclosure should be clearly labeled and identified to indicate the presence of gas piping within the electrical room. This labeling helps to prevent accidental damage to the gas pipe during maintenance or repair work, and it also alerts emergency responders to the presence of gas in the event of a fire or other emergency. Fourthly, adequate ventilation. Electrical rooms should be adequately ventilated to prevent the buildup of flammable gases in the event of a gas leak. The ventilation system should be designed to provide sufficient air circulation to remove any gas that may leak from the gas pipe. Fifthly, regular inspections and maintenance. The gas pipe, fire-rated enclosure, and sealing material should be inspected and maintained regularly to ensure that they are in good condition and functioning properly. Any damage or deterioration should be repaired promptly to prevent gas leaks or fire hazards. This includes checking for signs of corrosion, damage to the enclosure, and deterioration of the sealing materials. Sixthly, emergency shutdown procedures. Develop and implement emergency shutdown procedures for the gas piping system in the event of a fire or other emergency. These procedures should include instructions on how to shut off the gas supply to the building, and they should be readily accessible to all personnel who may need to respond to an emergency. The location of the gas shut-off valve should be clearly marked and easily accessible. Seventhly, consider alternative routing options. Before routing a gas pipe through an electrical room, consider alternative routing options that may avoid the need to pass through the electrical room altogether. If possible, it may be preferable to route the gas pipe around the electrical room or through another area of the building where it will not pose a hazard to electrical equipment or personnel. Eighthly, ensure proper clearances. Maintain adequate clearances between the gas pipe and any electrical equipment or wiring within the electrical room. This clearance prevents accidental contact between the gas pipe and energized electrical components, which could result in a fire or electrical shock. The NEC specifies minimum clearance requirements for electrical equipment, and these requirements should be followed when routing gas pipes through electrical rooms. Ninthly, use appropriate materials. Select gas piping materials that are compatible with the type of gas being transported and the environmental conditions within the electrical room. The gas piping material should be resistant to corrosion and other forms of deterioration, and it should be able to withstand the pressures and temperatures associated with the gas piping system. Common materials used for gas piping include steel, copper, and plastic. Tenthly, consider the potential for future modifications. When routing a gas pipe through an electrical room, consider the potential for future modifications or additions to the electrical system. Ensure that the gas pipe is installed in a manner that will not interfere with future electrical work and that it can be easily accessed for maintenance or repairs. This may involve providing extra space around the gas pipe or using flexible connections that can be easily disconnected. 11thly, document the installation. Maintain detailed documentation of the gas pipe installation, including drawings, specifications, and test reports. This documentation can be useful for future maintenance, repairs, or modifications to the gas piping system. It can also be helpful for demonstrating compliance with applicable codes and regulations. The documentation should include information on the location of the gas pipe, the type of gas being transported, the fire rating of the enclosure, and the sealing materials used. 12thly, train personnel. Provide training to personnel who may be working in or around the electrical room on the hazards associated with gas piping systems and on the proper procedures for responding to a gas leak or other emergency. This training should include information on the location of the gas shut-off valve, the signs and symptoms of gas exposure, and the proper use of personal protective equipment. 13thly, perform pressure testing. After the gas pipe is installed, perform a pressure test to verify that it is leak tight. The pressure test should be conducted in accordance with applicable codes and regulations, and it should be performed by a qualified technician. The pressure test involves pressurizing the gas pipe with air or another inert gas and monitoring the pressure for any signs of leakage. 14thly, consider grounding and bonding. Ensure that the gas pipe is properly grounded and bonded to prevent the buildup of static electricity, which could create a spark and ignite flammable gases. Grounding and bonding involves connecting the gas pipe to a grounding electrode, such as a ground rod or a grounding grid, to provide a path for stray electrical currents to flow safely to ground. 15thly, avoid direct contact with electrical equipment. The gas pipe should not come into direct contact with any electrical equipment or wiring within the electrical room. Direct contact could create a path for electrical current to flow through the gas pipe, which could result in a fire or electrical shock. If the gas pipe must pass near electrical equipment, it should be insulated or otherwise protected to prevent direct contact. 16thly, consider seismic bracing. In areas that are prone to earthquakes, consider providing seismic bracing for the gas pipe to prevent it from being damaged or dislodged during an earthquake. Seismic bracing involves supporting the gas pipe with straps or other hardware that is designed to withstand seismic forces. The seismic bracing should be installed in accordance with applicable codes and regulations. 17thly, consult with a fire marshal. In some jurisdictions, it may be necessary to consult with the local fire marshal before routing a gas pipe through an electrical room. The fire marshal can provide guidance on the applicable codes and regulations, and they can help to ensure that the gas pipe is installed in a safe and compliant manner. 18thly, use explosion-proof fittings. If the electrical room is classified as a hazardous location due to the presence of flammable gases or vapors, use explosion-proof fittings for the gas pipe connections. Explosion-proof fittings are designed to contain any explosion that may occur within the fitting, preventing it from spreading to the surrounding area. 19thly, consider the consequences of a gas leak. Before routing a gas pipe through an electrical room, consider the potential consequences of a gas leak. A gas leak in an electrical room could create a fire or explosion hazard, and it could also expose personnel to toxic gases. It is important to take all necessary precautions to prevent gas leaks and to have a plan in place for responding to a gas leak in the event that one occurs. 20thly, follow manufacturer's instructions. Follow the manufacturer's instructions for installing and maintaining the gas pipe, fire-rated enclosure, and sealing materials. The manufacturer's instructions provide important information on the proper installation techniques, materials, and maintenance procedures. Ignoring the manufacturer's instructions could void the warranty on the equipment and could also create a safety hazard. 21stly, use qualified contractors. Use qualified contractors who are experienced in installing and maintaining gas piping systems and fire-rated enclosures. Qualified contractors have the knowledge, skills, and equipment necessary to perform the work safely and properly. They are also familiar with the applicable codes and regulations, and they can help to ensure that the gas pipe is installed in a compliant manner. 22ndly, consider the impact on future maintenance. When routing a gas pipe through an electrical room, consider the impact on future maintenance of the electrical equipment and the gas piping system. Ensure that the gas pipe is installed in a manner that will not interfere with future maintenance work and that it can be easily accessed for inspection and repairs. This may involve providing extra space around the gas pipe or using flexible connections that can be easily disconnected. 23rdly, perform a hazard analysis. Before routing a gas pipe through an electrical room, perform a hazard analysis to identify potential hazards associated with the installation and operation of the gas piping system. The hazard analysis should consider factors such as the type of gas being transported, the potential for gas leaks, the presence of electrical equipment, and the potential for fire or explosion. The results of the hazard analysis can be used to develop safety procedures and to select appropriate protective measures. 24thly, ensure proper signage. Provide proper signage in the electrical room to warn personnel of the presence of gas piping and to provide instructions on what to do in the event of a gas leak or other emergency. The signage should be clearly visible and legible, and it should be placed in a location where it can be easily seen by personnel entering the electrical room. 25thly, review and update procedures. Review and update the safety procedures and emergency response plans regularly to ensure that they are current and effective. The review should consider any changes to the electrical system, the gas piping system, or the applicable codes and regulations. The updated procedures should be communicated to all personnel who may be working in or around the electrical room. In summary, routing a gas pipe through an electrical room is possible under the NEC, but it requires careful planning, coordination, and adherence to specific safety requirements. By following the guidelines outlined above, you can minimize the risks associated with this type of installation and ensure the safety of personnel and property. Remember to always consult with qualified professionals and local authorities to ensure compliance with all applicable codes and regulations.